Hello. I would like to welcome Mady Mantha, who will be presenting her talk, Buildable, Scalable, State-of-the-Art AI. At Magnimind, we want to find speakers who can deliver talks like these that are able to provide an extra step of education to go along with our data science boot camps and programs. These programs are designed to build the fundamental knowledge needed for a career in data science, either our mini boot camps or find your first job in the industry or another job in the industry through either our mentorship programs or our full stack data science boot camps. This week, we've been going through kind of a bit of a theme, AI, and the future of AI, and we kind of explored already what it's going to look like in the future and other techniques and ways it can be used. This talk will be about the way we can use conversational AI and maybe have computerized assistants in the future. Mady Mantha joins us from the Artificial Intelligence Advisory Council, which is a part of CompTIA, which aims to explore the vastness and possibilities of what AI can provide to humanity and try to regulate these technologies based on what they already can do or what they will be able to do in the future. Mantha, who's actually a Georgetown graduate, has BS in both computer science and international politics. So she can provide a perspective from both the computer data science side of what AI can do technically, and then also the legal side of what barriers there are to AI and how maybe we'll have to work around that. Tonight, we'll be mainly focusing on, again, the conversational part of AI and its uses in that field. And at Magnimind, we are extremely excited to host her. So we would like to ask you now to give your full attention to Mady Mantha. Thank you.
Oh, hi everyone. Thomas, thanks for that introduction. Yeah, it's really great to be here. I hope everyone's staying safe. I know we were supposed to meet in person, so thanks to April and Thomas for making the switch to a remote meetup and a remote conversation so seamless. It would have been great to meet you all in person, and hopefully we can do that soon. So thank you for being here this evening. If you have any questions, please just post them in the Zoom chat and I'll be sure to get back to you on those. And if something comes to you later, feel free to reach out on LinkedIn or Twitter or something like that, and we can totally chat about anything you might have questions about. But I'm really excited to be here to talk to you about some of the stuff that we've been into. So just a quick outline of what we're going to talk about today. I'll start by outlining a maturity model for conversational AI. Happy to do a quick introduction to conversational AI, but I'm sure all of us here are familiar with this since that, we're data scientists or in the data science field. And then I'll talk about the components needed to build successful and performant AI assistants. So we'll touch upon state-of-the-art NLP research and how we apply it, engineering best practices, and an efficient software development workflow with CI/CD, version control, and training data. We're also going to cover how to empower citizen developers to meaningfully contribute to conversational AI and sort of reference that theme and talk about this theme of how to move from a POC or a pilot project to production. So I'm going to try to talk about all of those things today. And like I said, if you have any questions during the conversation, just feel free to post them in the Zoom chat. A little bit about me and what I do before we start. I know, Thomas, you covered some of this already, but I'm a senior technical evangelist at Raza. I'm also a machine learning engineer. So I spent a few years building ML-driven products and tools for the enterprise. And a little bit about Raza too before we begin. So Raza is building open source conversational AI and is building the standard infrastructure layer for conversational AI. Our mission is to empower everybody, citizen developers and all makers, to build really great AI assistants. And I strongly believe that you don't have to be a machine learning researcher to build AI assistants. So we've been trying to sort of democratize, if you will, conversational AI. And a way that you do this is by building tools that are free and open source, focus on developer education, and champion other open source tools as well. And we focus on the developer community and try to empower them as best we can. And we also do a lot of research on natural language processing and natural language understanding and ship applied research to solve real world problems. So, conversational AI is not a new concept by any means, right? It's actually something that's been around since the 1960s when MIT first released their ELIZA bot, which was an open domain system, meaning that it can talk about anything that the user wants to talk about. So it's not new by any means, but for a few years, especially since 2016, it started experiencing a renewed focus and a renewed interest. And I think that's because right around that time, Google announced this big thing that we were moving from a mobile first to an AI first world where you expect technology to be naturally conversational, where we can talk to it just like we're talking to each other right now. We expect technology to be thoughtfully contextual so that it learns and remembers things about you. And that's what personalization is all about, right? And we also want technology to get better over time, to get more intelligent with each iteration. And so with this trend, we saw this proliferation of chatbots, or what we like to call contextual assistants or AI assistants. So this was in 2016 when people started talking to AI assistants, and everyone thought it was going to be this great thing that can talk about anything and that it would be super intuitive and amazing, right? But if you've talked to chatbots, especially in 2016 and in the following couple of years, you'll know that that wasn't the case at all. The AI assistants weren't all that intuitive. They weren't that intelligent. They weren't capable of understanding natural language in a way that humans do, even in narrow domains. So, what went wrong, and why were these expectations so high, and how was there such a huge gap in delivering that sort of reality? And it's sort of what you see here on the screen when you interact with an assistant, and you ask it a question and it answers it, but you ask a follow-up question, or you digress or engage in a conversation that doesn't follow an if-else condition that you may have coded, or it doesn't follow something that was maybe conditional logic, and it immediately fails. So that's the problem that I think we, people in the conversational AI community, practitioners and developers and researchers are all trying to solve today is how can you move beyond if-else statements and rules, and how can you get rid of state machines and use machine learning and data to create truly contextual assistance. I think right before this conversation, I checked out the Q&A tab. April, by the way, it's working. I know it wasn't before, but I think Dave, you had a question about, is it truly better than search? Because when you type something into Google and Bing, you were saying that it works very well for you, but maybe talking to assistants doesn't. So I'll go back to your question, but if I'm understanding that correctly, you were asking about how natural language is much better than that, right? And so we'll sort of get into what we mean by contextual assistance and, are all assistants created equal? And the short answer is no. There are many levels of AI assistants and their maturity model is defined by their capabilities. So let's quickly walk through that now. So at level 5, you have notification assistance. And at this stage, it is essentially, a traditional notification assistant. It can send you notifications about certain events or reminders about things in which you've explicitly expressed interest. So you say, notify me of this particular event or activity. And at that point, it will just send you a notification saying, here's a new email, or, here's a new newsletter, or if you're talking about your pizza delivery bot letting you know that your order is on its way or something like that, essentially push notifications. And they're 100% driven by rules and if-else statements, and there's no machine learning at this point. And at level 2, you have a basic FAQ, or frequently asked questions, assistant. Think of it like a response bot or an info bot. You can ask the assistant a simple question and expect a pre-built response. It can even handle some basic back and forth and dialogue. But everything here is still rule-based and powered by if-else statements or state machines. Even at this point, intent identification and entity recognition, and we'll talk about what that means in just a few minutes, that still happens, but the dialogue management, getting a response back to the user, all of that is still powered by, not powered by machine learning. And this is the most common type of assistant that we see today. And then we have, level 3 assistants, what we like to call contextual assistants in the community. This assistant is able to understand context or what the user has said before and when and where and how they said it. For instance, if you and I were talking about things like office supplies, or if I were to say to you, hey, I'm on my cell, you'll know that I'm referring to my cell phone and not like a biological cell or something. If you and I were talking about office supplies and I said, I need to order some pens, you'll know that I'm talking about pens as in instruments of writing and not pens as in like livestock pens or animal pens, right? Based on the context. And that's because humans understand context. So if you're building a financial assistant, the word bank will mean financial institution, not a riverbank. And there's many different examples of this, right? So the word balance means cash balance in this context and not the balance of things, not neutrality, and so forth. So context is critical when it comes to building a truly, like the name suggests, right, contextual assistant. Level 3 assistants are also capable of understanding and responding to different and unexpected inputs. So you probably already know this by now, but human language is incredibly messy and unpredictable. If you're building a weather assistant, and the one job of the weather assistant is to tell you what the weather is like, well, it may seem simple and you may think, well, we can totally build an FAQ assistant, and you could, and it will work to a certain point, but there's 40,000 different ways you can ask about the weather. So it may not be possible to input all 40,000 different utterances or input all 40,000 different ways a conversation could go, even if it's a simple assistant that does like one or two things. That's simply not scalable. So you still want to account for that complexity. So how do you do that if you're only using rules, right? So you do that with machine learning policies that can learn from existing examples, that can learn from existing data and generalize based on those examples. And accuracy is great, but if you have enough examples and the right machine learning policies, you're really able to generalize. And generality, which is again, not an absolute term, but a matter of degree, generality is something that we try to strive for. And at level 3, the assistant will learn from previous conversations and improve in accuracy and generality over time. So level 3 assistants are possible today, and you can use Raza to build level 3 assistants. And at level 4, the assistant gets to know you over time, and as a result is super personalized to you and your use case. These types of assistants aren't necessarily possible today, but we might get there in a few years after we can make level 3 the norm. And if we can make level 3 the standard, then we can totally focus on how to get to the next level and scale and make that possible on a scale. And at level 5, the assistant is not only able to do everything that a level 4 assistant does, but it can also run entire parts of a company's operation. So it can run lead generation for a company, or it can run sales or part of sales for a company. It can, it's able to run like HR or finance, and not just that, but it can also run a host of other assistants, and it can probably delegate tasks to other assistants. So this, again, is in the future. It's not possible today, but if we can make level 3 the standard, if we can make level 4 possible, then that's something that we can work towards together. So, conversational AI, just like we talked about when you were talking about the capabilities, is not solved, far from it, right? And conversational AI is not easy. It's actually a really difficult problem to solve. If there are any NLP scientists or researchers at this meetup right now, you'll know what I'm talking about. If we have data scientists, you'll know what I'm talking about. Conversational AI is a very difficult problem to solve because language is very messy and unpredictable. And this is a great image of something that looks like an airplane, right? And I'm not going to take credit for it. It's actually something that Francois Chalet tweeted, and he said, if something looks like an airplane, but doesn't fulfill the function of an airplane, which is to fly, then this thing here that you see on my screen, is that truly an airplane? And the answer is no. So, if something mimics natural language, or if something just does statistical and language mimicry without truly understanding natural language and its relationship with the world, then it's not truly natural language understanding. And that's just something that seems like it. So level 3 is hard, but we can get there. And we are building those level 3 contextual assistants today. And one of the components that you need to build a really successful level 3 assistant is great research. The past 2-3 years actually have been amazing for NLP, and the past 18 months or so especially have been just amazing in terms of the research that's coming up. You know, we talk about BERT and all these large scale pre-trained language models giving better and better representations and better accuracy. You know, the benchmark like glue is out and super glue is in. So so we saw Google's BERT, right? Google released BERT, which stands for bidirectional encoder representations from transformers. It became super popular. It's an NLP pre-training technique released by Google. And one of the cool things about BERT is its ability to pre-train bidirectional contextual language representations modeled on a large text corpus or corpora. And as a result, the pre-trained BERT model can be fine-tuned with just one additional output layer to create state-of-the-art models for a wide range of NLP tasks and downstream NLP tasks like question answering, language inference, named entity recognition. And it can do all of that without any kind of substantial task-specific architecture modifications. So this was great. And it allowed us to create better applications with better representation and accuracy. And large scale, you know, pre-trained models in general have shown promising results on language understanding benchmarks. We mentioned GLUE and SuperGLUE earlier. And in particular, they've also shown a lot of improvements over other pre-training methods like GLOVE and, you know, definitely over supervised approaches. And since these embeddings are trained on large scale natural language text corpora, they're also well equipped to generalize across tasks. And that's another thing that we've been trying to move towards is, you know, artificial general intelligence or generality. I don't want to talk too much about AGI because, you know, we're very far away from something like that. But in general, large scale natural language text corporas, if you train them on that, they're well equipped to generalize across tasks. And you know, here's what happens with conversational AI and dialogue systems in general. There are two main sort of components to this. We definitely want to use the latest research to improve both of these components to build great AI systems. And the first part is the NLU part, and the second one is dialogue management. And within Rasa, the goal of NLU is to extract structured information from messages. And the most important parts of a message are what we call intents and entities. So, you know, let's say you wanted to check in this particular example, you know, you're talking to your assistant and you say, how much money did I spend at Starbucks? And when you say something like that, what are the two most important things that you want your assistant to understand and learn from it is, first is your intention, which is you want to search your spending history, right? And the second part of information, you know, that's the intent. That's what the user is trying to achieve here. And the second part of information that you want to extract is the entity, which is the vendor here, Starbucks. Because, you know, if you say, how much money did I spend? It's important for your assistant to know what exactly you're talking about, like your spending history overall, or are you referring to a particular transaction? So that entity there is a key piece of information that we want to search for and extract. So that's the natural language understanding part. And then once we've identified the intents and extracted the entities, the second thing that we want to do is we want to respond to the user. And dialogue management handles that. It decides what to do next. So it looks at the user's previous state using a state tracker, and it predicts the next best action the assistant should take. And this next action, it could be sending a message back to the user or calling a REST API. Or querying the database and then sending a response, right? And that next action is predicted by machine learning policies and training data that we have in place. And the more data that you have, the better. So your model trains on that and is able to better generalize from that. And if your machine learning policies are also super performant and accurate, obviously you have a better chance of making a reasonably intelligent prediction as to what to do next. And if you have a system like this, you don't need if-else statements, you don't need rules. Of course, you need some rules to get started with, like business logic and some conditional logic in place, but you don't need to chart out every way a conversation path could go. And you wouldn't be able to do that anyway, because users, humans will act in ways that you can't necessarily anticipate at all. So the state of the conversation tracker gets determined by previous events, what happened before, including information from NLU and previous actions. And then once an action gets executed, once a response is sent back to the user, by the way, you spent $12 at Starbucks, that particular action also gets added to the tracker. And this happens in a loop every time there's a user message. And this loop is essentially the conversation you have with users. User sends a message, NLU kicks off, the intent gets identified, entities get extracted, dialogue management figures out how to respond to the user based on machine learning policies and previous actions, response is sent, and then that gets added to the tracker and the whole thing goes on. As long as there is a conversation between the user and the assistant. So we talked about BERT, right, and other large-scale language models and how they're super performant. I also want to talk about joint NLU systems that also improve upon current state-of-the-art and give you better accuracy, better performance based on actual empirical experiments. And this is something that the Raza team, the Raza research team released, and it's open source. Feel free to go out there and try it out. And let me know what you think. Super interested in your feedback. So this new neural network architecture for natural language understanding is called DIET, or Dual Intent and Entity Transformer. It's a neural network architecture that does intent classification and entity extraction together. So it provides the ability for you to just plug and play various pre-trained embeddings like BERT or GLOVE or Convert. Convert is just another very light scale language model that is trained just on conversation data, on data from Reddit. So it's also a super cool language model that you can try out. There's an academic paper on it. Happy to share that with you as well. So DIET provides the ability to plug and play all of these pre-trained embeddings. And in our experiments, there wasn't a single set of embeddings that was always the best or consistently better across different data sets. And we tested based on SNPs data and complex NLU data sets. So having a modular architecture, therefore, is super important. And having this modular architecture fits into a typical software development workflow, and it's developer friendly. And that's important because if we want to encourage citizen developers and empower everyone to build great assistance and contribute to conversational AI, that's important by making it accessible, and democratizing it. So we can go into a little bit detail into what DIET is and what it does. I'll do a quick summary. Basically, how this happens is raw text is split into tokens. This diagram, by the way, is based on an academic paper that we're about to release, and I'm happy to share this with anyone that wants to see it when it's released. So if you want me to, if you want to send me a message, if you want to see it, I'm happy to share it when it's released. So how this happens is that raw text gets split into tokens. So if you see below here, you'll see play, ping pong, right? So let's imagine, like in our previous example with Starbucks, you said, how much money did I spend at Starbucks? Or if you wanted to say, I want to play ping pong here, playing a game is the intent, and the game that you want to play is the entity, in which case, in this particular case, it's ping pong, right? So you say, I want to play ping pong. All of this raw text is split into tokens. And in the simplest case, it's just splitting those words, that sentence into words with white spaces. The words are then represented numerically with vectors and then processed even further by identifying the intent and the entities. And the tokens, as you can see here, are processed in a feed-forward fashion. A sequence of entity labels gets predicted through a CRF, through the conditional random field layer that is on top of this transformer output sequence that corresponds with the input sequence. So for the intent labels on this side here, the transformer output for the classifier token and the intent labels are embedded into a single semantic vector space. We use the dot product loss to maximize similarity with the target label and minimize negative samples. So that's an implementation detail that we can also go into later if you like. So the result is this with diet. Diet outperforms state of the art even without any pre-trained embeddings, as you can see there. And diet outperforms fine-tuning BERT. So if you had to fine-tune the BERT model, when you fine-tune the BERT model, diet outperforms that process and is also 6 times faster to train and improves upon the current state of the art. So really exciting results that we're seeing here. Because, you know, BERT and other language models tend to be not so developer friendly because they're so large scale and they often need GPUs to train. But diet is seen to outperform BERT, and you can also fit this into your own very consumable developer friendly workflow. So we talked about how NLU happens and the various language models and joint NLU architectures that make that happen, right? And the second part of that is after you recognize the intents and the entities, how does dialogue happen? Like we talked about machine learning policies before, and I said, well, you need machine learning because the more performant your machine learning policy, then the better chance you have of being able to generalize from those training data examples and be able to better respond to the user without rules, right? So how does this machine learning policy kick off? And how does the assistant figure out how to respond to the user? So you can have rules like we talked about before that do this, and you still do have rules in the case of level 2 assistants. So if the user asks about what Starbucks is, then just write a rule. If user asks about this, then tell them it's a coffee place, right? But rules don't scale beyond a certain point, even though they're very helpful for when you first want to get started. And that's because conversational AI requires NLU and it requires dialogue management. And the reason is that with rules, the happy path is already solved, right? So you're taking rules and you're trying to solve a problem that's already been solved. Maybe you're trying to make that easier to solve, which is useful, but it's super useful and helpful if you actually try to solve the problem that hasn't been solved yet, which is unhappy paths, which is what happens when users behave in unexpected ways, which they do, and then how do you have machine learning and data to respond to that without having it explicitly written, without having a state machine. Happy paths already solved, but as we talked about, real user conversations don't necessarily follow the happy path, right? Users often interject with off-topic messages. Like here in this example, the bot said, your total is $1,550. Is it okay if I charge the credit card you used last time? And the user asks, well, do I still have credit on my account from that refund I got? So that is a sub-dialogue, right? They did not follow the happy path and answer the question that you just asked, whether or not you should charge the card that they used the last time. But they engaged in a sub-dialogue, they digressed. So how do you handle that, right? Using something called the transformer embedding policy, which I'll not talk about, we're able to handle sub-dialogues and untangle all of these things. Users typically speak in a non-linear and non-sequential manner. So here, the assistant was able to sort of handle and untangle this sub-dialogue. And then the assistant said, shall I place the order? User says yes. And then they ask another question. They're going to loop back to an earlier topic, which was, hey, did you actually use my credit, right? So how do you anticipate something like this? And you can't anticipate all of the ways that users will react. And so that's why you can't use state machines and if-else statements, because an assistant whose purpose it is to automate conversations or handle a certain amount of customer service requests, for example, must be able to handle these types of conversations. And you want to be able to do that with all of this data that you're collecting anyway. And you want to be able to do that with machine learning policies. And so things like the transformer embedding policy can handle that, can handle sub-dialogues. And the TED policy has a predefined architecture. And what it does is that it concatenates the user inputs So that's the user intent and entities, previous actions, and each time step into an input vector. And then it feeds that to the transformer. It applies a dense layer to the output of the transformer to get the embeddings of a dialogue for each time step. And then it also applies a dense layer to create embeddings for system actions for each time step. And then it calculates the similarity between the dialogue embedding and the embedded system actions. So in other ways, it's a way to handle uncooperative user dialogues on fewer training data or fewer examples. So it uses these examples and is able to generalize from these examples. It looks at previous conversations, trains on them, so that when it sees something unexpected or something that it hasn't seen before, it is now better equipped to make a reasonably confident or a reasonably accurate prediction as to what should happen next. And based on that, what should I respond with? And then it responds with whatever it received from its prediction. So no rules, but data and machine learning, specifically attention, the attention mechanism, to solve for sub-dialogues and multi-turn interactions. But what we learned in our experience, and what I learned in my experience, was that NLU and NLP isn't really enough. You need engineering best practices to really be able to go to the next level and take your assistant to level 3, right? So you still need sound engineering and things like CI/CD and version control, and most importantly, you need tools. You need all of these things that you use in a typical software development workflow to really scale conversational AI projects and to go from POCs to production. So, and the best way to do that is to enlist the support of your developer community, and open source is great for that because we have a lot of developers contributing to our tech stack and teaching us and talking to us about better ways to do things. So with conversational AI development, what I think really works is you try to follow a typical end-to-end development workflow for managing all of your assistant updates and for managing your assistant development. So the way this works is that you make changes to your Git, your local Git, using your favorite IDE or a text editor, and you commit and push to the remote Git repository, which is very similar to a typical workflow for building software. And based on how you've set your things up, pushing changes to your Git repository triggers the CI/CD pipeline. And like a traditional CI/CD pipeline, the CI part of it, which is continuous integration part of it, builds, trains the model, runs tests, and the CD part of it, which is either, stands for continuous deployment, or I've heard people say continuous delivery too. You could say both. I've been using it interchangeably, so I hope that's right. And the CD part of it deploys the model with an optional manual review. And this happens as you continue to do iterative development. And this is how we recommend that you do development with conversational AI, is treat it just like you would any other typical software development process. Still follow the best practices of CI/CD, of test-driven development, write tests for your assistant, follow the 12-factor app methodology, make purposeful and meaningful integrations with third-party services. So if your assistant's purpose is to be a help desk assistant, then it makes sense to integrate with an incident management system like ServiceNow. So those integrations still need to align with your goal of what you want your assistant to do. And so all of these, all sorts of good practices, best practices around software development are still applicable and necessary. So if you follow that approach, that's one way to really continue to keep building a level 3 assistant, but also scale it from a POC to an in production enterprise grade assistant. So we also wanted to make that, at least that deployment aspect of it, easier by abstracting away some of the complexity involved in doing something like this, and still enabling you to follow best practices and automate a lot of things. So if you wanted to just create a VM, or a container and run a script like this, you don't have to use the script, but if you were to use the script, it would take you about 4 or 5 minutes, and you'd have a fully containerized deployment of Rasa open source and Rasa X. And what it does is that it installs Kubernetes, it installs Helm, installs a Helm chart with everything included. Let me just take real quick here. I thought I was getting some questions in the Q&A, so I just wanted to quickly check that out. Okay, but yeah, I mean, this is a way that we've abstracted away some of the complexity involved in deploying your assistant and making it production ready. So if you wanted to do that, it will take away all of the complexity involved in like installing Kubernetes on your own. K3s is just Kubernetes Lite, by the way, and installs Helm and a Helm chart with everything. And it's, you know, totally customizable and has a modular infrastructure. So you can still continue to use BERT and GPT-2. I actually, you know, worked on an assistant before where I integrated it with GPT-2 for natural language generation, which for those of us that may not be familiar with NLG is essentially something that allows your assistant to generate natural language on its own without being told what to say. So it's like generating all of that language on its own. And OpenAI's GPT-2, you know, came out and it was great. And I know Hugging Face also has like an open source GPT-2 PyTorch implementation of it that you can plug into. So, you know, you can use this for natural language generation, and that's fine for chit chat or small talk if you want to kind of have that in your assistant, right? But you don't want to really play around with NLG, especially because at this stage, it's not super mature and we don't have a true open domain system just yet. And that's still being developed at scale. It's still being operationalized. So you could run into issues with using something like NLG for your assistant. There still needs to be a lot of human validation at this point. I know Thomas mentioned like legal stuff earlier. So, you know, let's say you're building like you know, a mental health assistant that like primarily worked off of NLG, that you'd get sued very quickly should you do that, because what if it gives advice that or says something that it's not supposed to, and people take that advice, and so you could run into some problems there. Or what if, you know, in healthcare and AI, what if you're building a medical assistant, which is a diagnosis assistant, let's say. What you're doing is, let's say you train this assistant on ultrasounds and on, you know, specs in lung tissue and CT scans and things like that. And you envision this assistant to essentially give you like diagnosis advice. You know, what's wrong with this particular CT scan? Is everything okay? And then it says something that it's not supposed to. So, you know, you always need human validation for these kinds of use cases, whether it is somewhat trickier use cases like healthcare, where accuracy is super important and human validation is super important, or if you're using NLG for something like mental health, in which case you also need to be very careful. So yeah, I mean, you can play around with NLG because it's super fun. I remember I worked on this assistant and I said something like, well, do you like music? What kind of music are you into? And then it said, I like music, I'm into music, right? So it's not, if you're talking about the goal-oriented systems, that is essentially, you know, it's all right, right? It's not great, but it's fun for small talk and for other reasons. So you could still plug in BERT or GPT-2 or anything you like within Rasa, because it's open source and customizable and extensible. You could do whatever you want, essentially. But empowering developers and all makers is something that is super important. You don't have to be a machine learning researcher to be able to build really great AI assistants. And that's one of the reasons why we've shipped applied research and made them available in developer-friendly workflows. And the rest of the Rasa infrastructure as well, where we've tried to automate deployments and abstract away the complexity involved. So now I want to talk about how this fits into your stack. And, you know, if you're building conversational AI applications, what are the overall essential layers of conversational AI? So every conversational AI application is made of several distinct layers. You have the computational layer. That's where typically you have programming languages like Python and others exist there. You also have machine learning frameworks like TensorFlow, scikit-learn, you know, Spacey and other things, other components that exist at the computation layer. And then you have a layer on top of that, which is the conversational AI infrastructure layer. And you can use an open source tool that allows you to, that gives you the building blocks to build contextual assistance. And Rasa open source is one of those tools. One of those infrastructure layer platforms, I should say. And a layer above that is your tools and services layer, because tools are really important for you to continue to build AI assistants and continue to improve AI assistants, right? And RasaX is a tool set with a UI that allows you to annotate data, tag and filter conversations, visualize your conversations so you can fix them and make continuous improvements that we talked about. And that's why it's important in any software development workflows. If you have tools that sort of make maybe deployment easier, if you have tools that allow you to visualize conversations, if you have tools that allow you to collect metrics and analyze them, feel free to use all of those tools at this particular layer above the infrastructure layer. And above that, you have the application layer where your assistant resides. Now, it can live alongside other systems and web applications. For instance, if you're building an enterprise assistant, and enterprises payroll, HR and IT systems would live here. And in my earlier example, where we were talking about that help desk assistant example, that interacted with the incident management system and that IT system. So, at this layer, your assistant could interact with one or more of these systems. It doesn't have to, but in my example, it did. Applications at this layer also have user interfaces so that users will actually see and interact with those things. So like front-end channels like Slack, Telegram, WhatsApp, or chat UI widgets and so forth would also live here. And so the reason I have this diagram here is to, so use this analogy of, let's say you're making a pizza, right? And if you know how to make pizza, you'd know that you need raw ingredients for the dough. You need things like cheese, sauce, toppings, and ingredients for the dough or the dough itself, right? And you have three options here when you're making pizza or you want to have pizza. You can make all of the ingredients yourself. You could customize these pre-prepared ingredients and put all of the components together to make this pizza, or you could buy one with everything pre-built and pre-chosen that you can't customize, right? Just like you don't necessarily write your own programming languages, you're not going to write your own Python or your own TensorFlow. You might, if that's your thing, and that's great if you want to, but if your purpose is, or if your goal is to build a conversational AI application or a level 3 assistant, then you might not want to spend all of your time writing your own program language or your own ML framework. And so just like that, you're not going to create your own software conversational AI infrastructure. You don't have to build everything from scratch. You can customize and extend tools that are available and customize and transform them to create something that really, really works for you. So machine learning and NLP and tools alone are still not going to solve conversational AI. You also need training data because, and most of you here are in the data science field. You already know this, probably better than I do, but you need data. And for contextual assistance, that means real user conversations. So there's two types of training data that we look for in when we're trying to build AI assistants. So to train your intents and entities, you need examples or utterances or different ways of getting at that intent. So you want to give it enough examples so that your assistant is taught how to identify this particular intent. So for instance, in our Starbucks example, if we're trying to say, give it more examples on how to identify the intent of trying to search for transactions, you'd say, how much money did I spend? What did I spend on? How much money did I spend at Starbucks and so forth, like different ways, examples of getting at that particular intent. And for dialogues, you want to add stories and different ways of how a conversation could go so that your model trains on it and better generalizes from it. So you'd give it different happy pats, model out different ways. You start from like a greeting, you ask a few questions, you enter a few examples, and then you do a few unhappy pats, like ways a conversation could go wrong if a user were to digress or engage in small talk in the middle of a conversation. And you come up with enough examples that you feel comfortable with. And as soon as you have an MVP or a basic assistant, it's important that you use tools to make those continuous improvements, to test it as much as possible and as soon as possible, right? And one of the best ways you can make true improvements to your AI assistants is with real user conversations, real data. One of the reasons why the Convert model was really, even though it's super lightweight, but it's super performant, is because it trained on real conversation data. It trained on Reddit data. So it's important that we try to do this too. And if you use tools like RasaX or others, RasaX, by the way, is free. It allows you to train, it allows you to share your assistant with a link. You can share that with anyone you want, because it's important that you start testing it right away, and you want to make it easier for others, your coworkers, your colleagues, your friends, to be able to test your assistant. And if you're trying to deploy your assistant on Telegram or WhatsApp, it's not possible or feasible to add everyone to your WhatsApp instance or add everyone to your Slack workspace. So if you have a link, it's super highly effective, but like a super simple way that you could make it accessible to everyone on your team and others outside of your team, so they can talk to your bot and give you really valuable feedback. And you can use this tool to visualize your conversations and make those continuous improvements. And your data is still secure, proprietary, belongs to you. So, InfoSec considerations are really important. You want to make sure that you have something that's on-prem, or you have a solution that works for you, where you can still keep your data super secure and private. Okay, so to recap, conversational AI is not easy, and it's also not solved. Our approach and the recommended approach is that in order to build level 3 assistants and enterprise grade production assistants, and not just POCs, you need state-of-the-art research that allows you to achieve better performance, better representation, better accuracy, and better results. You also want to make this available in developer-friendly workflows so that you can empower everybody, and not try to be, exclusive. You want to empower, especially the developer community that, has a really good track record of shipping things to production and being successful in shipping things to production, right? So you want to include them as well and make this available in this flow so that all makers can build and contribute to conversational AI. And you also need data so that your machine learning models can better generalize from them and continue to get better and make those continuous improvements. And most importantly, you need tools that allow you to not just test conversational AI, but monitor, collect metrics. There's lots of metrics tools out there that you definitely want to integrate with and use, so that you can take a look at conversational AI metrics like user retention, like fallback rate, like abandonment rate, and all of these metrics that are really important for conversational AI. So you can take a look at those and keep making those improvements as you go on. And so that's been our approach to try to solve this really exciting and really interesting problem. We know that we're all in this together and learning together. So if you have any questions, feel free to send me a message. And if you have like feedback on how to better solve this problem, or if you have like an experience where an in-production assistant or something that you built, really worked, and you have a different way of doing things, please let me know. I'm super interested to learn how you did that. But yeah, so, feel free to get in touch. I hope you all have a great evening and weekend, and, thanks for sticking around and attending this session. I really hope we can do this again in person. I think that would be really fantastic. So let me stop sharing so that I can take a look at your questions. Okay, so I have a couple of questions here. Looks like Dave, okay, Dave, thank you. You asked 3 questions, so thank you for that. Okay, so has Mady or any attendee ever seen a natural language search interface that works better than just entering search terms? Oh, Dave, at the beginning of this, I think I probably misunderstood your question. I thought, because I just read search interface and I thought you were saying search works just as good, but I see what you're saying now. Okay, so in your experience with Google and Bing, it is less typing and it works just as well to enter search terms, not a complete sentence. So has anyone seen a natural language search interface that works better than just search terms? I think to a certain degree, most search is intelligent, right? I think that most search does natural language in some way, shape, or form. So if you can like qualify that statement, I think I'd be interested to know what you mean, so I can like better understand that question. So Dave, I'll just move on to your next question. Do you think people will use voice assistants for productivity tasks when they're sitting and working from home? What would be some examples? Okay, so great question. I think that's super relevant, especially today, because I think that everything, or like more things, will be voice-based and gesture-based going forward and not touch-based anymore, just because of the current coronavirus reality that we're living in right now. I think voice is super relevant. I know that lots of enterprises are doing some really cool things with voice. I know Alexa is super popular. And I think that it does have some productivity tasks and some productivity skills embedded within it. I know Google Assistant also does stuff like that, right? Where, again, this is my own opinion. I don't want to speak for Amazon or Google. I want to be really mindful here, but I know that with Google, you can hack some productivity tasks as well, skills that are embedded within it. I think that, Snips AI is some really cool, open source voice stuff that if you want, you can build some voice integrations using Snips. And I think it's super secure. So you can train it. If you have a Raspberry Pi, train it on your own server and build your own productivity tool. So I think that would be a very cool application of conversational AI. But yeah, I mean, I do think that people are going to be using more and more voice assistants for productivity, especially because they're working from home. And I think people will use voice because it's going to be super relevant, and people aren't going to be using touch as much. Okay. All right, Dave, another question from you. I'm wondering if speech recognition accuracy is good enough to search Stack Overflow with voice. If the user has to edit the speech recognition output to get the search they want, it might be easier to type in the search and not use voice at all. Okay, I mean, I think that ASR is pretty good. I know that Nuance does some pretty amazing things with speech recognition, and I know that speech recognition, just like image intelligence, is pretty mature. So yes, while I think that it can probably recognize your speech, of course there are issues with certain dialects and accents. And there's, of course, this huge bias and representation issue in machine learning, right? That it's not able to recognize certain accents that don't get enough representation in machine learning and in the data that we collect. So there's obviously that bias. So if you're saying that, can it recognize speech and can it search Stack Overflow using voice? I would say it depends on, the dialect and the accent. If it's someone from North America, I would say, yeah, I think so. Again, with Stack Overflow, it also depends not just on speech recognition, but also processing that natural language. So I think that has to be super accurate too and not get confused. So yeah, so that would be a challenge. But yeah, really interesting question. I'm wondering if you've built something like this. If you have, please share it. I think it's going to be super interesting for us to check out. Okay, Kelly, you say, are there many cognitive scientists involved in the dialogue of conversational AI in terms of finding new ways to create more intelligent models? Yeah, absolutely. I mean, I think that there's there's an entire field devoted to cognitive scientists doing conversational AI. And linguists focusing on conversational AI. We actually on my team have a developer advocate who has a PhD in linguistics, who's doing some really cool things with trying to figure out better ways to train models. But I think that this is something that's ongoing in research. People are actively trying to find ways to create more intelligent. I'm guessing by more intelligent, you mean better generality and also better accuracy, and so better performance. So if it's those things we're talking about when we say intelligent, then yeah, absolutely. I think that people are doing that. Okay, can you please provide links for the papers you mentioned on diet and the NLU deep dive? Yeah, absolutely. I mean, if there's a way that I can share that with April and Thomas, I can do that, and they can probably email it out to everyone who attended the meetup. So I'm happy to provide that information and any other links that I think might be helpful if you want to take a look at that, for sure. Okay, Abi says, I know Raza has been using ML for dialogue management, but I don't think any other platforms are doing so. What could be the reason? Is machine learning not very reliable for now? So, I mean, I can't really speak for what other platforms are doing at the moment. again, I want to be mindful when I talk about this. So, I mean, so I think your point about machine learning not being very reliable is an interesting one. It's an interesting comment that you make. And so I think the reason why that is some of the things that we talked about today was, you can't just have algorithms and think that, okay, this algorithm is like, this NLP algorithm is magic, and I'll just like integrate this with my assistant and it's going to do everything I need it to do. So you can't just do that. And you can't just have tons and tons of data and not have a machine learning policy that can sort of extract intents and entities very well, that's super accurate, and that can also try to, when it trains on this data, also try to handle uncooperative dialogue or things that are unexpected. So you need performant machine learning policies for both NLU and for dialogue management, right? And even if you have that, you still need to train it and you still need to make continuous improvements to your assistant. So you can't just have a great policy and some really great seed knowledge and say, all right, looks good, bye. You have to make those continuous improvements just like you do for any kind of iterative software development workflow. So you need, all three components. And then, even that might not be enough. So it's not just machine learning not being reliable, I would think, in my opinion. You also need tools, right, to be able to see how your assistant is doing or see how your program is doing. It doesn't have to be conversational AI, but metrics for other types of collaborative filtering problems, for instance. You still need to collect those metrics and see how your program is or your model is performing and make those improvements and try to fix them and continue to tune and push models out to production. So I think that it's an ongoing process and it has several different components, and you have to have all of these components to be truly successful. Okay, Brandon, what would be required if we introduce bot voice into the equation? So how would we incorporate it into the machine learning, since right now the bot looks at text in order to differentiate between the intent and entities when we ask? Thank you. Yeah, you're welcome. Okay, so yeah, I mean, you could definitely do a voice integration. You can use Rasa to build both text and voice-based assistants. So you could have voice data, and you could obviously do, there's a few components involved with voice, right? Speech recognition, and then speech to text, and then the text gets processed, tokenized, featureized. The entire process happens. It spits out the intents and entities. Dialogue management does its thing, and then it spits out a response back to the user. So I know that there's lots of open source speech to text APIs that you could use. We've been using a few, we as in like just me, when I've been playing around with stuff. So yeah, you feel free to use like, Google speech to text, for instance, or other APIs out there to do something like that. And then you could just call that API and plug that into your assistant. Okay. Yusra asks, can you share metrics and tools for metrics? How do you monitor for model drift? Okay, great question. I'm happy to share like some metrics tools that I am familiar with and that I use. So I can probably send it to Thomas and April and they can email that to you. But great question. Okay, Anonymous, can you talk more on the diet requirements and limitations? Does it have language limitations? Okay, great question. So diet is a classifier, right? It's a neural network architecture that does intent identification and entity extraction or entity recognition. So because it's a classifier, you could use that for any language. It doesn't have any kinds of language limitations per se. You just have to specify the language of your model, and you can continue to use diet to create multilingual assistants. And that's something that folks in our community have been asking a lot about, is how can you create multilingual assistants using Rasa? And there's ways you can do that. I can actually point you to some comments and questions in the forum that go over this. So I'm happy to send that over as well. Okay, Abhi, a follow-up, right, to your previous questions. What to do if there's no data to train a model for dialogue management? Okay, let me go up to your question real quick. So just remember, so previously you asked, all right, how, like, is machine learning not very reliable for now, and whether other platforms have also been doing machine learning based dialogue management. And so now your question is, what if there's no data to train your model for dialogue management? So I think if you can clarify what type of data you're talking about, that would be great, because obviously there are some models that come pre-trained, and there's some publicly available data sets too, like lots of public data sets out there that you can use. So if you in your enterprise, or you yourself, if you're trying to build an assistant and you don't necessarily have a lot of training data yourself, because maybe you haven't tested it or sent it out to real users to talk to and collect all of that data, because all of that data, you'll have to feed that back to your model to make it more performant. If you don't have that, you can still use public data sets. And there's always things like Reddit data, right? Twitter data. But obviously you need to do a lot of pre-processing and cleansing and so forth. And if you're a data scientist, you know that that takes up most of your time, is to clean data, process it, annotate it, tag it, and so forth. So I would say, like, I don't know exactly what your use case is, but I'm sure you could use some public data sets as well to train your model. And then maybe start talking to it right away. And then whatever you talk about, like all of what you're saying to the assistant is also data, right? Which can be useful. So there's 3 types of ways you could collect training data with real user conversations. You can talk to the assistant yourself. You could share it with your friends and colleagues and teammates, and you can actually ship it, release it to real users, and continue to collect data that way as well. So those are just some options. Okay. Olaseni, where can a novice developer start if I'm looking to use Diet? Oh, this is just a great question. I can send you those instructions on how to use Diet, how to get started with Diet. It's because it's like plug and play and a modular architecture, and it's a classifier that you could just add to your pipeline. Actually, if you wanted to get started with Rasa open source today, your NLU pipeline configuration file comes with Diet classifier as the default option. So if you wanted to go to like Rasa open source, go to get started and then just like download Rasa or do Rasa init and create an assistant, it will come with Diet. So you don't have to do anything really, other than like starting with Rasa to start to use Diet. It's just a classifier, it's a component within your NLU configuration file, and you could start using it, right away. You can, however, if you want to, you can fine tune it, right, with using various hyperparameters. For example, if you want, you can configure the neural network's architecture by specifying the size of the transformer, the number of transformer layers, things like the number of attention heads to use, and so forth. So those are all things you could do on top of that, and it's totally customizable. But if you just want to get started, just download Rasa. Diet classifier is the default option. Okay, Jessica asks how to handle slangs in our real life chatbots. Also, how to handle specific words that users might say. Here in Brazil, each state has their own ways to say the same thing. Do you see a way to handle this easily in Rasa? Okay, so how do we handle slang? And each state or each region, I think similar to the US to a certain degree, and similar to lots of other countries, each state would have their own way of saying the same thing. So how do you handle that in Rasa, right? I think that's your question, if I'm understanding that correctly. Yeah, great question. There is a way to do that, right? If it is just words, what you could do is, let's say these are custom entities that you wanted to create. Certain slang words are custom entities that you wanted to create. So you use like a custom entity extraction and you normalize that entity. So you say, well, this is the entity, which is like coffee. And then you could add all of these synonyms or different ways of saying coffee in a particular state or region, for instance. So that's like one way that you customize entities themselves. And with intents too, you could do something similar. You could group it by action. So for instance, if you're trying to train like idiomatic phrases or something, and you can group that by intent or by action, like what is the user trying to achieve or accomplish, and you add all of those different ways of getting at that particular intent, right? For instance, can I get an an extra pair of eyes on this is probably like not proper English, right? But what I'm trying to say is I would like some feedback, or can we collaborate on this? So if like that is your actual intent, you can add all of those as different examples. You could try that out. I know that that's not like a perfect solution. I know that we still have lots of limitations when it comes to slang and dialect and regional things, but you could try that. You could use custom entities, normalize it, add synonyms for intents, group them by action and have different ways of getting at that particular intent. Let me know. I mean, if you wanted to try that, if it works out. Okay, cool. Abhi, oh, thank you. Yeah, you're welcome. Cool. I think I got all of those questions. If I missed something, hey, Thomas.
Yeah, no, does anyone else have any other questions? Please speak now. If not, thank you all for coming to our talk, and we'll definitely get those links out as soon as we can to anyone. We'll just get those from Mady real quick. We hope to. The reason we have these talks is just to inspire people to kind of just keep continuing their learning and keep applying what they learn here into their work and into their lives. We really just appreciate everyone coming out, and we appreciate Mady for coming and speaking. Thank you so much. We also hope that you will join us on April 6th for our talk, Introduction to Graph Analytics with Victor Moe. So we'll kind of switch subjects from AI to something else. And then thank you and have a good evening.
Right. Thank you.